Mergesort is a popular sorting algorithm that uses a divide-and-conquer strategy to sort a list of elements. The algorithm works by first dividing the input list into two halves and recursively sorting each half. Once each half is sorted, the two sorted halves are then merged back together to produce the final sorted list. We will look at an example of sorting a list using mergesort. Example 1. We will use this array and sort it using mergesort. The first step is to divide our array into two halves. This means that we get two subarrays, one consisting of 7, 5, and 6, and one consisting of 8 and 2. We will again split our left subarray because it has not been sorted yet. This results in us getting an array with 7, 5 and an array containing 6 as its only element. The left array is still not sorted, so we divide it again, this time resulting in two subarrays with both containing one element. We can view an array with only one element as an array that is sorted. We can now merge these sorted subarrays back together. The subarray that was the last one that got split is now the first one that will get merged. This means that we first merge 7 and 5 back together. The way we do this is by each time finding the smallest element out of both subarrays and putting it in the new subarray. 5 is the smallest element here, and we will therefore put it in the first slot. We put 7 in the last slot since it's the only element left. Next up is merging the sorted array consisting of 5 and 7 with the sorted subarray that only contains 6. We start by finding the smallest element out of these two subarrays, which is 5. We add 5 into our new subarray. We now add 6 into the subarray since it is the smallest element from both subarrays. Last up is adding 7 since it's the only one left. We have now sorted the left half of our starting array. Let's sort the right half of the array and merge both sorted subarrays. The sorting of the right half is done the same as the left half. First we split the arrays since it is not sorted yet. We will then merge these new subarrays since we can't split them anymore. We first put 2 in the array and then 8 since 2 is the smallest number out of both subarrays. Our right half is now sorted, so it's time to merge the left half with the right half. This is again done by first finding the smallest element and putting it in the first spot. Then we find the next smallest element and put it in the second slot. You get the idea. Time complexity. The time complexity of mergesort is O and log n, where n is the number of elements in the input list. This makes it one of the most efficient sorting algorithms for large input sizes. Thanks for watching, and check out this video about insertion sort if you want to learn more.